Our last topic in the module is solving equations with fractions. Okay, let's bring the fractions into play. So what's going on here? Now we're in a situation where we have fractions and more than two of them. So you can't just be like, oh, I'm going to cross multiply to get rid of the denominators. Okay, so we're going to use the lowest common denominator again, but it's a little different because this time we're going to multiply every single term by the entire lowest common denominator. So we're not looking at what's missing and multiplying in a fraction. We're just bringing it in, and we're using it to cancel our denominators and get rid of fractions. How does it work? So looking at number 1, I see one fraction. And yes, you could just make 3 over x as a fraction, 3x into 21 over 7, but this is just a quick way to do it. So I know that my lowest common denominator in this situation is 7. So essentially what I'm doing is I'm taking each term and multiplying it by 7. To get it in there. Okay, when I do that, look to the fraction 1, because there is where you're not going to make 35. You're going to right away use that LCD to cancel out the denominator. So this is my next step, not making 35. And then I rewrite. So that first term has just become 5x. My second term has become 28. And my third term has become 21x. And proceeding with our normal algebra steps now, I'm going to send the 5x over to the other side. When I do that, it's going to be negative, so I have negative 28 equals 21, I'll write it down, 21x minus 5x. And then I have negative 28 equals 16x, and then I get x is going to be negative 28 over 16. Those are both divisible by 4, so always reduce those fractions, and you're going to have negative 7 over 4. Okay, looking at number 2, and I'm actually going to just kind of resize this and get it out of my way. Get it over there. Okay. So at number 2, I see my denominators are 8 and 2, so my LCD is 8, because 2 can go into 8, and I'm going to do the same thing again. There's the 8 multiplied into the first fraction. There's the 8 multiplied into the second fraction. And not forgetting to multiply whole numbers by 8 as well. We're not going to make 40 over 8. We're just going to right away do this. In our second one, it's more like a reduction. So our terms become 5 for the first one, plus 4x equals 32. Send the 5 over. 4x equals 32 minus 5, which is 27. And x is going to be 27 over 4. Leaving in that fraction form, that's fine. I'm not going to take off marks to make a decimal, but the program might initially. And just knowing that 5 plus 4x equals 32 is the same equation as the original question. It's just been multiplied by 8. Like it's 8 times as large, but same equivalent. All right, let's look at number 3. In this case, my LCD, I need 4, 3, and 2 to go into it, so my LCD is going to be 12. And same thing, so even if I just, no, I'll rewrite it. I was going to be lazy and do it on top, but that's not going to work. So 12 times 3x over 4 plus 12 times x minus 5 over 3 equals 12 times 1 over 2. Okay, next step, canceling those denominators out. So 12 over 4 is the same as 3 over 1. And 12 over 3 is the same as 4 over 1. And 12 over 2 is the same as 6 over 1. So I'm going to have 3 times 3x plus 4 times x minus 5 equals 6. 9x plus 4x minus 20 equals 6. 13x equals 26. X equals 2. Okay, algebraic denominators. We know how to do this too. So we're looking at what we have. We have in number 4, we have some numbers and we have some x's, and I need something that 6, 8, and 12 will go into, and off the top of my head, I'm going to say that's 24. And looking at x's, I have x to the power of 1, x to the power of 1, and x to the power of 2. So in order to fit that in, I need the highest power. So this is what I'm going to multiply everything by. Okay, so multiplying in 24x squared. And yes, you can just put in what's missing and drop the denominator. There are faster ways to do this, but I'm just trying to do it the way that doesn't get stuff left behind. And if you do this step and you still have a denominator, you picked the wrong LCD, because all those denominators should go into it. Okay. This will cancel, this will become 2, and this will be plain x. This will cancel, this will become 3 plain x, and all of the x words cancel, and this becomes 4. So let's assemble here. My first term is 2x, my second term is 3x, and on the right side I have 4 onto x plus 2. So I have 5x equals 4x plus 8, and then move the x's to the left side, and I'll have x equals 8. Number 5. Okay, I see a 4 and a 2 for numbers, so I know that my LCD will have a 4 in it. And I see a couple of the same binomial to the power of 1. So don't force it, and don't incorporate it, just leave it factored like that. That is fine. So taking up a bit more room now. Here we go. We're going to have 4 2x minus 3 times the 3 that was already there. And in our second term, we're just going to put it all on top because that was a 1. And in our third term, 4 2x minus 3 times 5, and it's going to be over that 2x minus 3. Put some brackets on. Canceling green. So we know we're going to get rid of it all. Cancel, cancel. Changes to a 2. We're just going to get rid of the 4s. And here we're just going to get rid of the binomials. So we're going to have, I'm going to write it as step still, and then we have that 2x minus 3, bracket it for the moment, don't really need to, and on the other side we have 4 times 5. So 6 plus 2x minus 3 equals 20. Okay, so 3, move it over to the other side. And x equals 17 over 2. Okay, leaving myself more room. So looking at this LCD, lots of stuff going on. I see number 4 by itself, so it's in. I see plain x's, not binomial x's, here and here, only to the power of 1. And then I see x plus 3 here and here. So make sure you're comfortable with getting the right LCD. Okay, so we're going to multiply that into each term. And that's over x plus 3. Kind of make this one negative sign as big as possible so I don't mess things up. Okay, and then we're minusing 4x plus 3 times the 5 that was already there. And that equals 0. Okay. Okay, x and cancel, 4x and cancel, x plus 3, x plus 3. Okay. See what's left. Okay, we have 12x. 4x times 3 is 12x. And then we have this subtraction, so we're going to have to distribute it to both things. So it's going to be subtract x, subtract 3. And then we have another subtraction, and 4 times 5 is 20. Equals 0. Cleaning it up, 11x minus 23 equals 0. 11x equals 23. X is equal to 23 over 11. Something that you just never would have guessed. Last one. Okay. I feel like this is going to be ugly. We have a plain old 2. We don't have any x's, but we have 2 different binomials. So this is going to be massive. And that's our LCD. So for our first one, we are going to multiply in the LCD. There was a 2 already there. It's going to be over 2x minus 1, x plus 4. The original denominator stays. Second one, multiply in that LCD. Times 1, so I don't need to show it. And multiply in the LCD. There's a 3 already there. Leave yourself lots of room when you do these ones. Okay, let's do some canceling. All right, get rid of these binomials. Much nicer. Get rid of these. Get rid of those. And on this one, okay, not so bad once we do this. Rough for a minute, but it doesn't look like we're making any quadratics to factor, so that's good. All right, what do we have left in the first one? 2 times 2, just 4. On the second one, we have that x plus 4. It's a subtraction, so it's minus x minus 4. And on our third one, we just have, distribute the 3. 6x minus 3, I almost didn't see that. Equals 0. Okay, so we've got 5x, 4 minus 4, minus 3 equals 0. X, 5x equals 3, and x equals 3 over 5.